Dear friends, welcome back to the chapter Refraction of Light. In the last and the third video of this chapter named Refraction of Light, we are going to discuss about formation of a rainbow and problems based on refractive index. First of all, we will learn about the formation of a rainbow. The rainbow is always fascinating to us in our childhood. The formation of a rainbow is a combined result of refraction, dispersion and reflection of sunlight by water droplets. The rainbow is resulted due to the three phenomena of lights, and these three phenomena of lights are refraction, which we are learning in this standard, dispersion and reflection. These three phenomena, they combines together and the result is a rainbow. After raining, the tiny water droplets present in the air, they acts as a prism. We know that the sunlight is a mixture of violet, indigo, blue, green, yellow, orange and red colors. So, the tiny water particles or droplets present in the air after rainfall, they acts as a prism, and when sunlight incident on these water droplets means prism present in the air, there is a number one refraction and dispersion of light as it passes from air to water, means the refraction of light and dispersion of light is taking place as the sunlight is going from rarer medium to denser medium. Second, there is a internal reflection of light inside the droplet, because the outer side of the droplet, it behaves like a mirror, so that's why the internal reflection of light takes place. Third one, refraction of light takes place as it passes from a water to air. The refractive index of water is different for different colors. Refractive index is maximum for violet color and minimum for red light. So, there is a refraction of light as it passes from air to water. Now, let us learn how the process takes place with the help of a diagram. The combined action of different water droplets produces rainbow with the red color at the outer side and violet color at the inner side. Here we have to keep in mind one thing, that large number of water droplets, they acts as a large number of prisms, and due to the combined effect of this large number of water droplets, the rainbow is formed in the sky. Now let us learn this phenomenon with the help of a diagram. In this diagram you can see that here a beam of white light is incidencing on a water droplet. When the light is going from a rarer medium to the denser medium, there is a refraction of light, means there is a change in the direction of propagation. At the same time, this droplet, water droplet, it behaves like prism, so that's why there is a dispersion of light. Here this side of water droplet, it behaves like a mirror, so that's why the internal reflection of light takes place. And again, when the light rays which are going from a denser medium, means from a water droplet to the air, there is a formation of the rainbow. So in this way, in nature, the rainbow is formed. In this section, we are going to deal with the problems based on the refractive index. So the first problem is, the velocity of light in a medium is 2 into 10 raised to the power 8 meter per second. What is the refractive index of the medium with respect to air if the velocity of light in air is 3 into 10 raised to the power 8 meter per second? To solve this problem, first of all, we have to find out the data which is given in this problem. In this problem, we have to find out the refractive index of medium with respect to air. That's why the first medium will be air. So, velocity of light in air, which is V1, is equal to 3 into 10 raised to the power 8 meter per second. Velocity of light in medium 2 means V2 is 2 into 10 raised to the power 8 meter per second. Now what we have to find out? We have to find out the refractive index of second medium with respect to the first medium. So that's why the formula will be refractive index of second medium with respect to first medium. That means refractive index of medium with respect to air equal to velocity of light in air divided by velocity of light in medium. From the data, we will put the values in the formula. Velocity of light in air is 3 into 10 raised to the power 8 divided by velocity of light in medium is 2 into 10 raised to the power 8. 10 raised to the power 8 and 10 raised to the power 8 is cancelled. That means 3 by 2 and 3 by 2, that means 1.5. So, the refractive index of second medium with respect to first medium is 1.5. We will take another problem. The velocity of light in a transparent medium is 2.4 into 10 raised to the power 8 meter per second. Calculate the absolute refractive index of the medium. In this medium, in this problem, we have to find out the absolute refractive index of medium. In this case, only the velocity of light in a transparent medium is given, while we doesn't have given the velocity of light in other medium. So that's why the velocity of light in air is 3 into 10 raised to the power 8. So we will calculate, we will find out the data from this problem. Here we have to find out the absolute refractive index of the medium. Therefore, velocity of light in air, which is indicated by C, is 3 into 10 raised to the power 8 meter per second. Velocity of light in transparent medium is taken as V, which is equal to 2 into 10 raised to the power 8 meter per second. We have to find out the absolute refractive index of the medium. That's why the formula will be absolute refractive index of medium is given by C upon V. That means velocity of light in air divided by velocity of light in medium. The velocity of light in air is 3 into 10 raised to the power 8 divided by velocity of light in medium is 2.4 into 10 raised to the power 8. 10 raised to the power 8 divided by 10 raised to the power 8 and cancel. So that's why the equation becomes 30 divided by 24. The solution is 1.25, means the absolute refractive index of medium is 1.25. This is the same problem as that of the second problem. If the speed of light in a medium is 1.5 into 10 raised to the power 8 meter per second, what is the absolute refractive index of the medium? First of all, we will find out the data from this problem. In this problem, only the speed of light in medium is given, that's why the other medium is air, and therefore the velocity of light in air is 3 into 10 raised to the power 8 meter per second, while velocity of light in a medium is given in the problem, that is 1.5 into 10 raised to the power 8 meter per second. So the absolute refractive index is given by n equal to c upon v. Here c is velocity of light in air and v is velocity of light in medium. The velocity of light in air is 3 into 10 raised to the power 8 divided by velocity of light in medium is 1.5 into 10 raised to the power 8. 10 raised to the power 8 and 10 raised to the power 8 will be cancelled. So the last equation will be n equal to 30 divided by 15. The final answer is 2. That means the absolute refractive index of medium is 2. Now we will take one more example and somewhat complicated problem. If the absolute refractive indices of glass and water are 3/2 and 4/3 respectively, what is the refractive index of glass with respect to water? First of all, we will find out the data from this problem. In the problem, the absolute refractive index of glass is given, which is indicated by Ng. It is 3/2. The absolute refractive index of water is already given in the problem, that is Nw equal to 4/3. We have to find out the refractive index of glass with respect to water. So we have to find out refractive index of glass with respect to water. Now in the problem, the absolute refractive index of glass is given, that is the Ng, which is nothing but it is c upon Vg. Here c is velocity of light in air divided by velocity of light in glass, which is 3/2, means the absolute refractive index of glass is 3/2. Similarly, refractive index of glass is given by Nw, which is also c upon Vw, which is equal to 4/3. Now we have to find out the refractive index of glass with respect to water. To find out the refractive index of glass with respect to water, we have a formula: absolute refractive index of glass divided by absolute refractive index of water. So the formula is c upon Vg divided by c upon Vw. By putting the values in the equation, we will get 3/2 upon 4/3. Now the equation is 3/2 into reciprocal of 4/3 will be 3/4. So that's why 9/8. So the refractive index of glass with respect to water is 9/8. That means 1.2.